Alright, one final day of systems and elimination, so we're just doing some practice here. Okay, remember, we look to see if the values, variables, numbers are lined up. Then we're going to either add or subtract. Look for the same coefficient, -2, +2. Same coefficient. If they're the exact same, then we add or subtract. If they're opposites like this, then we add, because we're trying to get it to be 0. So 5 plus -4 is 1x. -2 plus 2 is 0y. That's what we want to happen. 3 plus -12 is 1. So x equals 1. Then we take that variable with its number, substitute it in, and solve for the other one. 5 times 1 is 5, minus 2y equals 13. Subtract by 5, we get -2y equals positive 8. Divide by -2, and y equals -4. So there's my answer. We write it as an ordered pair. 1, -4. Okay, number 2, same idea. Are they lined up? Yep. Add or subtract? Well, -1 and -1 would mean we would have to subtract. So negative minus a negative is going to give us 0x. -1 minus -1, remember that makes it a positive. It's also 0y. -7 minus -4 is -3. So 0 plus 0 equals -3. Remember, we have those 3 special cases. Like number 1, we have where they intersect, and we get one answer. Number 2, when we get rid of both our variables and the answer is not true, that's our second case with parallel lines, right? Which the answer was no solution. So that's the answer to number 2. The third possibility is when we get rid of both our variables, but these end up being true, and that's when it's overlapping lines, which is infinite solutions. But for number 2 for us, no solution. Okay, taking a look at number 3, they're not lined up, so we're going to have to swap it around. So I could add a 3x on this bottom equation, add a 3y to the opposite side, and we'd end up with 3x equals 3y minus 30. And on the top here, we've got that 3x equals, just swap positions, 3y minus 30. Now, what you should notice right off the bat here is that these are the same exact lines. Okay, you can go through this process and say, well, let's subtract. 3 minus 3 is 0x. 3 minus 3 is 0y. -30 minus -30 is 0. 0 equals 0 plus 0. So 0 does equal 0. That's true. That was our third situation. So the answer here is infinite solutions, because they're the same line. So those are what our 3 types of answers look like. So now we can just get busy solving the rest, knowing what the answers look like, and making our judgments based off that. So this one's kind of a similar setup. So let's add 9x here. So we get -30 plus 9x, and then we'd subtract 3y, so we get -3y. Now I cannot worry about that one, and I've got those two. So a -3 and a -3 means we've got a minus. So, and if you have to, take the coefficients in the numbers and write them out like this. -20 minus -30. Well, that's really plus, so that would be a positive 10. Okay, 7 minus 9 would be a -2x. -3 minus -3, 0y. So we add the 2x to both sides. We get 10 equals 2x, divide by 2, and 5 equals x. Okay, which tells us this is going to have one solution. Pick one of my equations, plug in 5 for x, and solve for y. So -20 plus 35 equals -3y. 15 equals -3y, divide by -3, and we get -5 equals y. So our answer intersects at 5, -5. So we just keep going on. These ones are all lined up, so we're off to a good start. The problem is they're not the same numbers, right? No coefficients are the same. Well, so I look at them all. Can I make this 3 and 4 the same? Yeah. Can I make 9 and 18 the same? Yeah, and that one's actually easier, isn't it? Because I can just multiply by 2, and then I get to 18. So that's what we're going to do. So we've got our first equation, negative 18x minus 4y equals 0. Then we double our second equation to get a positive 18x plus 6y equals 0. Now we can add them, because negative 18 plus positive 18 is 0x. Negative 4 plus 6, 2y, 0 plus 0. So 2y equals 0, divide by 2, and y equals 0, which is alright to have. Then we go 9x plus 3 times 0. 3 times 0 is 0, so 9x equals 0, divide by 9, and x equals 0. So these intersect at the origin, 0, 0. And that's alright to have. Some of you might get confused and think that might be no solution or infinite solutions, but it's not. 0, 0 is a point. Okay, our lines intersect right there. Now let's look at number 6. They're lined up, but once again we don't have similar looking coefficients. But 5 can easily become 10 once again if I double it. So I have to times every piece by 2. So I get negative 10x minus 10y equals 0, and negative 16x minus 10y equals negative 6. So I'm going to have to subtract these. So if you need to, write out your coefficients like this. Because we know minusing a negative is actually adding. So negative 10 plus 16 is positive 6x. Negative 10 plus 10 is 0y, which is what we want. 0 plus 6 is 6. So 6x equals 6, which means x has to equal 1. Then we pull one of our equations down and substitute 1 in for x. This part we should know how to do. We've had a ton of practice on this. Negative 8 minus 5y equals negative 3. Add 8. We get negative 5y equals positive 5. Divided by negative 5, y equals negative 1. So our answer, 1, negative 1. That's where it intersects. Okay, number 7. Same idea. They're not matched up, right? So I can either multiply the top or the bottom. Doesn't matter which one. I can make the 5 10 or the 6 12. So we've got 12x plus 5y equals negative 24. Rewrite the top equation. Then 2 times 6 is 12x minus 20y equals negative 24. Then we subtract, because 12 minus 12 would give us 0x. If I added that, I'd have 24x minus 15y. If I don't get rid of one of my x's or y's, I did something wrong. So that's a quick way to check. 5 minus negative 20 is like a positive 25y. Negative 24 minus negative 24 is 0. So divide by 25, and I get y equals 0, which is alright to have, remember. We still have our variable. Take one of my equations. Instead of y, I put in a 0, and solve. 6x equals negative 12. Divide by 6, x equals negative 2. My answer, negative 2, 0. Okay, number 8, same idea. So I'm going to times the top by 2, and that gives me negative 12x minus 12y equals negative 4. Now notice my x's and my y's are exact opposites, but my other numbers aren't. Chances are this is going to be a special case. And you should know exactly which one it's going to be, because I get rid of my x and my y, however I don't get rid of my other number. So I end up with something that is not true, which means no solution. I can notice it right there. Those are opposite, same. Whereas if we look back here, oh, I think I erased it. There was another one, right? That was exact same. And we could see that. Okay, number 9. So they're all lined up, but now here's a problem. 5 can't become 3, 3 can't become 5, 5 can't become 4, 4 can't become 5. However, these two can both become 15, so I'm going to times the top by 3 to get 15x plus 15y equals 30, and the bottom by 5 to get 20x plus 15y equals 0. then 15y and 15y, so we can subtract 15x minus 20x, negative 5x, 15 minus 15, 0y, 30 minus 0 is 30. So negative 5x equals 30, divide by negative 5, x equals negative 6. Plug it back in to one of my originals. You don't have to use these new ones to plug it back in. And typically they're bigger, so I like to do it this way. So negative 24 plus 3y equals 0, add 24 to both sides. 3y equals positive 24, divide by 3, and y equals positive 8. So there's our answer, negative 6, positive 8. So on number 10, if you look at that one, same idea here, right? No way to get 3 and 7, one to be the same as the other, so we have to make them both. Well, 3 and 7 can both become 21. That's the smaller of the two, so that's the one I'm going to go with. So we times the top by 7 and the bottom by 3. So we're having to just make them both bigger so that we can actually make this work with elimination. And sometimes that's the way it's got to go. And that's the toughest type of problem, is when you have to do so much extra work just to get them to work. So we're going to subtract here because they're the same sign. So negative 49 minus negative 24, that's like adding it. We know this one's going to be 0y. And we know this one, negative 21 minus negative 21 is 0. So this one, negative 49 plus 24, would be what? Negative 25x. So negative 25x equals 0, which tells us x has to be 0. Because if we divide anything by 0 by anything, it's still 0, which is fine to have. Then I put 0 into my next equation. That cancels out. Negative 7y equals negative 7. Divide by negative 7. Y equals positive 1. So my answer is they intersect at 0, 1. Okay, let's just keep on working here. So now, these are big numbers and ugly, right? Because 9 and 7, 27 and 21. Now, there's another route we could go. We could try making these smaller, because 27 could be divided by 9 to become 3. 21 could be divided by 7 to become 3 as well. So I could divide these all by 7, giving me negative x plus 3y equals negative 2. Oh, worked out. And this one we could divide by 9, and it's going to work out too. This very rarely happens, but I'll show you what it looks like when it does. So we get negative x plus 3y equals negative 2. Oh, and look what happens. They become the exact same number. So even if you would have multiplied by 7 and 9, you would have ended up with the same exact equations, which tells us what? There's infinite solutions. I don't need to solve this out. They're the same exact equation. They're going to be 0 equals 0. It's going to be infinite solutions. Okay, let's look at number 12 now. Kind of the same idea here, but I don't think this would work to divide. Nope. Because 5 can't go into 7, 7 can't go into 5. So that's not going to work. And I can't make a 6 of 5. I could divide it by 2 or 3, but I can't subtract it by 1. Okay, you cannot subtract to do anything. You have to either multiply or divide to change them. So, let's see. 5 and 6 can become 30. That's probably going to be our best bet. So times these by 5. So we get 30x plus 50y equals 4 times 5 is 20, negative 70. Then we multiply this by 6. So negative 30x plus 42y equals, that's what, 2, 4, 12, 162. And we're going to add them, because positive and negative. So that becomes 0x, which is what we want. This becomes plus 92y equals, and that's going to be negative 92. So divide by 92, we get y equals negative 1. Take that and plug back into one of our originals. So negative 5x plus 7 times negative 1 equals 27. So negative 5x plus negative 7 equals 27, right? Or did I get something wrong? Y of negative 1 would make that negative 5x plus 7 times negative 1 equals 27. So we add 7 to both sides. Negative 5x equals 34 divided by negative 5. That's not looking right. What did I do wrong? Something's wrong here. Because that number's just not looking right to me. And most of these are set up so their numbers are nicer. You could have a fraction like that. Let's see. 162 minus 70. Maybe that's where I made my mistake. 2 borrow 16. No, that's 92. It's positive 92, isn't it? That's where I made a mistake. And notice how one misplaced negative or positive can totally screw up your answer. Because that would be positive 1, making that positive 7, meaning I subtract by 7 instead of adding 7, meaning 27 minus 7 gives us 20 divided by negative 5 is negative 4, which is a much nicer number to deal with. And that's part of the problem with systems, is one small mistake like that totally screws up your answer. So you've got to be aware of those. Okay. 13 and 14. Ugh. Now, first of all, these are fractions. Notice they have the same denominator. We are multiplying this whole thing by 7 to begin with. So negative 7x plus 1/7 times 7 would give us y equals, those would cancel out, giving us negative 19. Okay, then I need to add the 7x. So we end up with y equals negative 19 plus 7x. That's an x. Then I can rewrite this one below it. Negative 5y equals 23 plus x. And it doesn't matter what you have above or below, as long as you have them lined up. So now we want to probably get this one, this y, to be a 5. So we need to multiply everything by 5. So that would be 5y. Negative 19 times 5 would be 0, no, actually 5, 4. 5 times 1 is 5, plus 9, 4 is 9, so negative 95. And then 7 times 5 would be 35x. Okay? Now we can add them, because that would be 0y equals negative 95 plus 23 would be negative 72. 35 plus 1 would be 36x. Add 72 to that 0. 0 equals 0 equals 72 equals, let's try that. Apparently I've been doing too many problems here because I'm making stupid mistakes. So I get 2 equals x. Plug it back into one of these equations. Negative 5y equals 23 plus 1 times 2. 1 times 2 is 2, plus 23 is 25, equals negative 5y divided by negative 5. And we get y equals negative 5. So, 2 negative 5 is our answer. Okay, number 14. So, these aren't lined up, are they? So we need to swap it out. So I could add 4 to both sides and subtract 4x to both sides. So it would basically be negative 10y minus 4x equals 4. Now to match these up, notice 4 times 2 is going to give us 8. 10 times 2 is also going to give us 20. So times by 2, and let's see what happens. So we've got 20y plus 8x equals 12. That's going to be negative 20y minus 8x equals 8. Now notice these are the same but opposite, but those aren't, so let's see what happens. So we add 0y plus 0x equals 20. 0 and 0. Does 0 equal 20? Nope. No solution. That's our parallel lines. Alright, last 2 problems here. So, now this one looks like it's not going to work, but think of that as adding 0. So it would be negative 2x plus 0 equals negative 2y. Then we'd need to double these, right? Times it by 2, so we get negative 2x minus 12 equals 2y. Now if we subtract here, negative 2x minus negative 2x is 0x. 0 minus negative 12, positive 12. Negative 2 minus 2 is negative 4y. Those ones didn't eliminate. So you've got to be careful. You may always want to do this to double check. Divide by negative 4, and we get negative 3 equals y. Pick one of these. I'll take the top one. Negative 2x equals negative 2 times negative 3. That gives me 6. Negative 2x equals 6. Divide by negative 2. And x equals negative 3. So our answer, negative 3, negative 3. Okay, so sometimes they may look like they might be a special problem, but they aren't always going to be that way. So let's start off by multiplying this one by 5. Okay, I'm also going to need to get this equation to match up. So regular number y, regular number, so add 5x to this side. So this equation becomes 3y minus 8 equals 5x. This, when we times by 5, cancels out those 5's. So we're left with the y term first, negative 3y, plus the regular number, 11, equals negative 5x. We add these together. Negative 3 plus 3 is 0y. 11 plus negative 8 is 3 to the positive. Negative 5 plus 5x is 0x. Does 3 equal 0? Nope. So once again, no solution. Alright, so there we go. There's your practice with elimination. We are now done with all 3 methods of finding systems. So we should be so super excited because we've spent quite a bit of time talking about systems, and now we are done. So, yay.